This recording shows you how to evaluate limits of function involves recursive function and also using squeeze theorem. Our problem is find the limit of x goes to 0, x squared times sine of 50 over cube root of x. Note that the limit when x goes to 0, sine of 50 over cube root of x does not exist. Now this problem uses squeeze theorem. According to the squeezing theorem from section 1.6 of Harvard Anton text, let f, g, and h be functions satisfying g of x less than or equal to f of x less than or equal to h of x for all x in some open interval containing the number c, with the possible exception that the inequalities need not hold at c. If g and h have the same limit as x approaching c, say both limit is L, then f also has the same limit as x approach c, that is, limits of f of x when x approach c is L. Here's our problem now. Limit of x goes to 0, x squared sine 50 over cube root of x. Now, let's do the calculation in this way. First of all, we know sine of 50 over cube root of x is always between 1 and minus 1. This is the property of sine function as long as x not equal to 0. Now, if I multiply the inequality everywhere by x squared, since x squared is non-negative, so the inequality will remain the same. So the inequality will remain. Now, this is what I mean by the function g of x equal to minus x squared, h of x equal to x squared. So the function f of x is the x squared times sine 50 over cube root of x. So this inequality holds for any interval containing 0, right? Holds for any interval containing 0. And according to the squeeze theorem, we need open interval contain 0. So, okay, this is a open interval contain 0. For example, can be from minus infinity to infinity, except at the point 0. Since we know we cannot put x equal to 0 into f of x, but this is okay because it's mentioned with possible exception need not to hold at c, where c equal to 0 now. So by using the squeeze theorem, limit of x goes to 0, g of x is limit of x squared, which is 0, and limit of h of x, which is limit of g of x was minus x squared, right? Limit of h of x, or limit of x goes to 0, x squared also 0. Both limits are equal now. So by squeeze theorem, limit of f of x when x goes to 0 must be equal to 0 now. And that is the end of the recording.